Good morning, everyone, and hello. Welcome to today's SEG webinar, Essential Skills for a Modern Economic Geologist, with series speaker Benedikt Steiner. My name is Deanne Ryder, and I'm the Online Community Manager here at SEG, and I'm the webinar coordinator for this series. I will first cover some logistics for the webinar and give a quick overview before Benedikt gets started. If you have any problems viewing today's webinar on your screen, such as it screen freezes, just try to refresh your screen using Control 5. That should fix the problem in most cases. If you still have problems or you have problems hearing today's audio, you can join you can click the arrow next to the Join Audio button and select Test Speaker and Microphone, or you can also call into the conference line. But just keep in mind that charges might apply. Today's call will be listen only, but we encourage participants to ask questions during the webinar by using the Q&A button at the bottom or top of your screen, depending on how it shows up. The questions on the presentation will be answered during one of the two Q&A sessions. Today's webinar is part of a four-part series targeting the needs of students and early career professionals. It's being recorded and an archive will be available following the event. You should receive an email with the link to the webinar page, or you can also view it on our SEG YouTube channel. I encourage you to register for other upcoming webinars, and details are available on the SEG website. Here's the list of the next events. I wanted to call out that there's a date change for the November webinar. It's changed to the 13th, and I will be sending out an email with that change following today's webinar. And with that, I wanted to take a quick poll just to see how many people, who we have on the call today. We have some great answers coming in so far, and I'll just give it a few more seconds before showing the results. So hopefully everyone can see the poll on their screen right now, just asking if you're a member and where you're coming from. Okay, I'll give it a couple more seconds and then. All right, let's see what we have. And I will share the results with everyone. So great, most folks here are SEG members, but there's a fair amount who are not. A lot of individuals are coming from industry, and we have a wide range of experience level here. So for those of you who might not be familiar, but it seems most of you are, SEG is a society devoted to advancing the science, discovery, and responsible development of mineral resources. We're an international organization with members all across the world, predominantly in North America, and then a large portion in Australia as well. We have 118 student chapters, and we have early career committee connecting students and senior professionals. And this just gives an overview of where our student chapters are at the moment. If you are interested in finding out more about a student chapter or how to start one at your university or college, you can go to the website segweb.org/students to find out more. And with that, I will turn it over to Benedikt. Benedikt Steiner is our SEG webinar series. And I will grant you control in just a second, Benedikt.
Great, thanks, Deanne. And welcome everyone to the second webinar in this webinar series. Today we are going to look into essential skills for economic geologists. Just move forward here. A second. So I think, Deanne, if you could move the slides, it doesn't seem to work here.
Benedikt, give it a try again. I'm going to close this.
Yeah, I think it's better if you move it, please.
Okay.
Yeah. Right. So sorry for the short delay. And again, welcome to the second webinar in this series. And we originally had the idea to come up with a number of educational sessions on the topic of economic geology, with the aim to raise the awareness of economic geology and especially help you, and I mean by that early career professionals and graduate students, help you to find your feet in the minerals industry. We would also like to open up this to provide guidance to essential job skills that are really needed if you're working in mineral exploration, mining, or related fields. Next slide. So today we are going to look into the top 10 skills that I believe are really critical in the minerals industry. We're going through them, and I explained to you a bit more what I believe geoscience graduates or early career professionals, what skills they should develop. Following this, I will present a few ideas and explain how these skills can be obtained through practical work experience or by studying specialized MSc programs. And for the professional members amongst us today, I also will give you a couple of ideas how to actually make use of the so-called CPD, the continuous professional development, to help you advance your career in the mining industry. Next slide. So last webinar, we have set the scene already, but just for those who didn't manage to attend, I quickly summarize the key points once more. The mining industry actually is quite a varied, offers varied employment opportunities, and all of those can be placed along the mineral resources development cycle, if you like. And this development cycle describes all activities that are related to mining and the minerals industry. Now, usually that cycle starts off with the exploration phase. That's where geologists go into the field and aim to find mineralization and evidence for an economic and mineable ore body. Following this, you usually have environmental impact assessments and approvals, which is granted by the government or environmental authorities. If those permits are all granted, the mine construction can usually start, and ore deposits are mined for a number of years, and that really depends on the size of the ore deposit. Usually when these operations close down or are near the end of their life cycle, we have the so-called rehabilitation and closure process, where the so-called the disturbance to the environment that's been done by the mining is attempted to be reclamated. Now, all along this mining development cycle, you will find job opportunities or career opportunities as a geologist to advance your career. And as I said, today we're going to look into the top 10 skills that I believe you should look into or you should acquire if you would like to advance your career in mining. And I think we have, before we start off with these skills, we have a short poll coming up. Deanne, if you could kindly move them in. Right, so I would just like to ask the audience what skills you think are the most essential for economic geologists. Do you think project management and organization is key to a job in mining and exploration? Or do you think communication skills are important, or actually the technical knowledge, so the pure geology aspects? Or do you believe soft skills and problem solving skills are of importance? So please take your choice and let's take a look what the audience thinks. Okay. Deanne, maybe you can show up the results of this quick survey. Great, so we seem to have almost 50% of the audience believes that technical knowledge such as geology and fieldwork is, those skills are critical in carrying out a job in mining and exploration. And then we've got about 33% believes that problem solving and creative thinking is the way to go. So that's very interesting. So I suggest let's take a look at what if that matches up with what I'm going to present. All right, let's move to the next slide and start straight off with skill number 1. Well, I believe that in mining and exploration, geological mapping and rock mineral recognition skills is absolute key, plus adopting a mineral systems approach. So in a way that sort of reflects the nearly 50% of you that have voted for the technical skills that are of importance. So what do I mean by these geological mapping and identification? Well, it's of course very obvious that if you are going to look and mine ore deposits, knowing and understanding that geology is key. But I really believe that you need to acquire the basic skills that you learn in your first university years. Those are really the key ones that will help you to be successful in mining. So what you want to do is not just recognize a rock or mineral, but you want to develop the ability to reconstruct geological history and development from the available rock and geological data that you acquire in the field. And that is critical as we in mineral exploration and mining, we would like to understand how ore deposits form. And here the concepts of the mineral system approach analysis really comes into play. So mineral systems analysis aims to combine and interpret information gained from different kinds of techniques and sources such as geophysics and geochemistry. And it's quite similar to what the oil and gas industry has been doing for decades. And mineral systems analysis tries to put an ore deposit into perspective. So you would like to analyze where's the source of the mineralizing fluid, how does it travel to the host rock, and how is it deposited there and forms actually the accumulation of economically interesting minerals. Now, this understanding is important in order to predict the occurrence and the location of ore deposits. And this can, of course, be applied to all sorts of mineral systems. I'm just giving two examples here. I've listed orogenic gold deposits and sedimentary hosted base metals. Now, in orogenic gold deposits, those of you who worked in this sector, you know that orogenic gold has a very, very strong structural influence. Usually these deposits are found near regional shear zones, and along these shear zones you have these mineralizing fluids traveling and then deposited in mafic or graphite-rich host rocks. Now, understanding this, these different structures and the structural development of an area, along with the chemical processes that take place in the host rocks, that's of course very, very important if you screen large areas for prospective structures and deposits. If we move on to skill number 2, I believe that here a bit of a soft skill. You should have definitely an interest, and you should show the willingness to spend prolonged stints in the field under sometimes difficult conditions, let's say. If and when we are looking for new deposits or actually mine them, nowadays it is in quite inaccessible regions. And I'm just quoting examples of northern Canada or Central Africa or the Australian outback. These areas are probably quite underexplored, but that's exactly what makes them attractive to mining companies. And if you're working as a geologist in these regions, you would probably have to adopt to the thought that you will be spending quite a considerable time away from home or from your base locations. And then that, depending on the location, can be ranging from weeks to months. All right, so I know that if you're working in Africa, you're usually spending there weeks or up to 3 months, while in other parts of the world, you probably spend just a week in the field and come back. Now, why do I mention this? Well, I think not everyone is comfortable in living such a lifestyle and being able to spend long periods of time under such conditions. So if you're still deciding whether this whether economic geology or mineral exploration is the right thing for you, I believe that you should consider this this point here carefully. And I guess what helps is always speaking to colleagues or industry contacts that you know who have done this kind of job already and can tell you about the different social aspects of such a work and lifestyle. If we move on to skill number 3, I think here's a very important aspect actually. Just take a look at the photo on the right here. That's a photo I took last year when I was on field work in Southeast Asia. And of course, you might ask yourself, what's not quite right here in this photo? Well, there are a number of things that are not quite right here, but I think all of them go back to the common aspect of health and safety. Now, what I'm using here, HSECs, that depends on the company you're working for, but it usually stands for something like health, safety, environment, and community. And these aspects are paramount, really paramount in the mining industry nowadays. So it's not just about getting a job done as quickly and as cheaply as possible. Well, that's a common attitude I've seen, but really nowadays, you will quickly realize that the mining industry has strict norms and regulations, and most companies that are operating in the minerals industry are having their own health, safety, environment, and community standards. I believe that mining and geology professionals should really adopt a positive attitude towards this aspect. So the aim is that you go on a work stint and you return safely and without any harm. Equally, that applies to the environment or the communities, the community sector you're operating in. So what I want to say by this is that the social and environmental aspect is extremely important in mining. That's usually not something that's been taught at university, but I would suggest that reading into this aspect could be quite a beneficial. Could be quite beneficial to you acquiring the awareness or the skills to succeed in the mining industry. If we move on to skill number 4, you can see here on the right-hand side these 2 photos here. They've been taken from a remote exploration project in the jungles of the Democratic Republic of Congo. You see there that on the top photo, everything is logistically being carried by hand in the jungle. There is absolutely no access there. Even the drill rig on the bottom photo has been hand carried through the jungle. And this is, of course, quite a logistical challenge and problem if you operate in remote areas. Now, often those kind of mining and exploration projects have a huge logistical tail. And what it means is that it's often quite a challenge to organize field programs and field projects efficiently. And what I learned in my career in the mining industry is that being able to solve logistical problems and acquiring these logistical skills is really, really important in order to actually carry out your normal job, which is geology. So I'm quickly giving you a couple of examples of what logistical skills or say situations you might encounter when you work out there in the mining industry. So first of all, I mean, some of you who read this, you probably have experienced this already, but those points are just some of the classics, I think. So for example, in such remote areas, if you're driving these large 4x4s or trucks, it's almost guaranteed that you get stuck in the mud at some point, especially in the rainy season. Now, getting your truck out of the mud is quite a sophisticated skill, especially if you haven't driven those large vehicles before. So I think that is something you will quickly learn if you're doing remote field work. Another skill I learned myself in the field was, for example, to organize water for a field camp or for a drill rig. Now, diamond drilling rigs, they consume nowadays up to 10,000 liters of water a day. Now, if you're operating in a desert, where would you expect to get 10,000 liters of water every day from? Now, that's a very interesting question. Do you truck it in from somewhere else, or do you drill a borehole and extract the water from this borehole? That might have some environmental implications. This is, of course, this is a very important aspect. Without water, it's very difficult to carry out any diamond drilling. Point number 3 here is set up and supervise project contractors. Every exploration project or mining project makes use of a whole range of contractors, whether they're drilling operators or first aiders or people supplying procurement services to your project. All of these need to be somehow organized and supervised, right? You of course want contractors to carry out a proper job. Now, that's also something that's usually not taught at university, but really an important skill to learn. So if you have the chance to start managing people during vacation projects, or if you're a graduate geologist, you may want to really get involved in this sort of area here. If you're a bit more advanced in the in your career ladder, you may be managing the roster rotations of your field crew. So what do I mean by that? Usually project managers, they manage how people move in and out of a field project, and whether they drive in or they fly into a certain location. All of this needs to be managed. And if you're having 50 people on your team, it can be quite a challenge to accommodate everyone's needs and wishes, and also fine-tune this with any flights or transport going in and out of the project site. And another very important aspect is to manage project budgets. Now, it's usually the case that budgets in mining exploration are usually quite tight. So you can't, of course, overspend money on a project, even though that sometimes happens. But it really requires careful understanding of where money is spent and how money is spent. And that's a key skill in running such projects, especially if they cost lots of money, like on the right-hand side in these photos. Yeah. So in essence, what I'm trying to say here is that geologists are not only involved with technical tasks. So they're not just going out and mapping an area or collecting soil samples or drilling and obtaining drill samples. Really, your role as a geologist will often involve logistical issues, and you have to deal with them rather quickly and efficiently in order to ensure a smooth operation of your project. Okay, let's move on to skill number 5. Teamwork, cultural and community awareness, as well as language proficiency. I'm sure many of you who already spent some time out in the field working with people from all around the world, you will realize that mining is a very global business. And it is not uncommon to have many different people from different cultural backgrounds, speaking different languages, and having different habits and habits on site. Now, this is especially true if you work in places like Asia or South America or Africa. As geologists, you're usually the first company employees on the ground, if you like. So the local population they will see the company through through how you act and how you behave. So careful community engagement is absolutely paramount in the mining industry. And as your team can consist of a diverse mix of backgrounds, that can lead to quite interesting team dynamics. And these team dynamics, they have to be managed somehow. So what I would like to tell you here is that running a team can be interesting. It can be also quite challenging. And importantly, working with many different people, it will require from you that you adopt to different views or different ways of doing and carrying out a job. Importantly here as well, additional language skills are really a must if you're working remotely or on remote sites. And if you speak other languages than English, that's often a very great advantage to be able to liaise and communicate with local people and even contractors. I've had many times the experience that if you try at least to speak a local language, that people will very quickly warm up to you and accept you as a professional in the team, because that just shows that you have the ability to fit into a different cultural background and community. So my recommendation to you is that learning other languages, it will really pay off over the long run. So you could think about learning Spanish, you could think about learning French, Russian if you work in more easterly directions. But also, of course, if you work in areas where you have different tribal languages, like here in Central Africa, as you can see on that photo on the right, if you simply learn a number of phrases or words, that will open doors, and people will make you feel welcome very quickly. Okay, on to the next slide. So yeah, we arrive at our first question and answer session. Let me have a quick look at the question and answer sheet here. And we've got an interesting question here. And the question is, management skills is a must-have. What about leadership? Absolutely. Leadership is very, very important. And in my opinion, leadership and management go hand in hand, right? So if you're running a team, if you're managing a team, you of course need to demonstrate that you're a good leader. Now there are of course different types of leaders out there. Some who are very direct and very active. Some other leaders are more passive and let other people carry out jobs. But really, it is about developing these skills that will put you in front of people and allow you to be accepted to run a program, run a project. One more question we've got here, and someone is asking, is reflected light microscopy still relevant to teach at BSc geology level? Now this is a very interesting question. Let me answer it like that. I still believe microscopy is important in understanding rocks and petrogenesis and mineralization suites. However, I have in my career in the mining industry, I've personally never used reflected light microscopy. If a question ever came up, it was either done by an academic at university or specialized consultant. So people may have different opinions about this, but I still believe it's important that you teach this and learn this at university. However, it needs to be clearly emphasized what the application of it is in the industry. And that could be along the lines of identifying properties for geometallurgical testing or process mineralogy. So if those applications could be emphasized, that would be fantastic. Great. There's another question here. How was your change from oil to the mineral industry? Okay. Well, maybe you've heard in my last webinar that I actually first worked in the oil industry and then moved into the minerals industry. So if you like, I can quickly elaborate on this one. Well, why did I change into the minerals industry? Well, for a simple fact that I really missed the fieldwork aspect in the oil and gas industry. I was sitting on a computer for a year almost and just digitizing well logs. Now, it might appeal to some people, but really after university, I personally wanted to really get out, get experience, really apply my geological skills to actual rocks. And in a way, yep, I definitely found this in the minerals industry. So in my opinion, this change was unproblematic. I did it very early on in my career. So I was not too deep into the oil industry at this stage. Yeah, so I hope that answered the question. All right, I think we should move on. Thank you very much. We have one other Q&A session in a short while. Okay, let's move on to skill number 6. And here it gets a bit more geology again. We've talked a lot about these soft skills and these management and logistics skills, but let's get back to some of the key geoscientific skills you will need. Nowadays, it has been for a while, but it's even more important nowadays with the depletion of the easy to find resources. It's very important to develop an ability to generate targets, exploration targets at great depth and under transported cover. You can see me here on the right. I'm up in Finland and I'm digging a series of quite deep holes through glacial till. Maybe some of you know that glacial till is quite an interesting material, as it has been transported for considerable distance. So if you just sample till, you may perhaps actually find an anomaly that's been transported for a long distance and it's actually not sitting straight below you. Now, as I said, in the bigger picture, most of the easy outcropping mineralization occurrences, they've been found. That's what's been said in most of the conferences nowadays. However, I believe that's not true everywhere, to be honest. I've been in places like Myanmar in Southeast Asia or in Scandinavia, where we have glacial cover, where deposits are not deep. In Myanmar, I recall a situation where I walked over an outcropping, a 10-meter wide outcrop of massive lead zinc mineralization. And this mineralization extended for kilometers along structural features or fault zones. In Northern Europe, in Scandinavia, the only problem you have is the till, right? Can be up to 10 meters thick, but then gold mineralization can be quite shallow. So we're not talking hundreds of meters deep. And anyway, the ability to generate targets through possibly transported overburden is very important. So the question here is quaternary geology, so quaternary landforms that have been produced by recent glacial action, is quaternary geology actually overlooked? I believe it is, because it's not commonly taught at universities, depending on where you study, and not really a big significance has been put onto it, but really understanding these transportation processes of and secondary dispersion processes of overburden material is absolute key in understanding where your soil anomalies are coming from. Okay, so let's move on to skill number 7. And skill number 7 is the understanding of the geological expression of geophysical data sets, and then relating this knowledge back to geological observations and regional geology. On that figure on the right-hand side, you can see an excerpt of an airborne magnetic survey. It's actually one of the best airborne data sets I personally have worked on. And you see here the already filtered, reduced to pole first vertical derivative filter of an area of this airborne survey. And really, the geophysicists who collect and process the data, they deliver such images to the geologist. Now, understanding what these images, these red and blue blobs mean, this is really important for us geologists, because such data sets help us in understanding the geology and the mineralization a lot better, and in a way help us to identify and establish a control on the mineralization system. In this image, for example, you can see or distinguish at least 2 deformational phases. There's one deformational phase which produced a fold, and there's another deformational phase which is actually reflecting a sinistral shear zone here, and it offsets the one limb of that fold to the west here. Maybe if you take a bit of a closer look at that, you hopefully will see what I'm talking about here. But this, of course, is of key importance if you're looking for structurally hosted ore deposits, such as orogenic gold or sedimentary hosted copper. You want to identify where are the key structural features in an area, and how are they related to mineralization. Now, such interpretation techniques, first of all, they're often not taught at university, and very often people pick up these skills by either mentoring, that a more experienced geologist is teaching younger geologists how to interpret such data sets, or they learn it by doing or attend workshops. But really, from what I see around, this skill is needs a bit more attention in university curricula. Importantly also is that geologists need to communicate to the geophysicists who can explain what these different mathematical derivations of the dataset and the resulting colors actually mean. So, if you ask a geologist what is reduced to pole first vertical derivative, geologists probably have struggled to understand the mathematics behind it. That's why it's important, if you know a geophysicist who can explain you this in great detail, that you learn from our colleagues in geophysics, and use this knowledge and these skills to fine-tune your structural interpretation, for example. A few other key techniques that have really become important in mining are 3D seismics and magnetotellurics. Now, 3D seismics has been in the oil and gas market for an extremely long time, but mining industry, we are currently waking up to the idea that 3D seismics could be interesting, especially if you study sedimentary or metamorphosed sedimentary basins. Magnetotellurics is a very useful tool. It's been around for a long time as well, but it's also in the last decade people have realized the use of it when exploring for deep deposits. Okay, let's move on to the next skill, skill number 8. And this is all about big data analytics. You may have heard about artificial intelligence or big data squeezing and all these data challenges that have been around over the last couple of years. During PDAC, over the last few years, there were always the winners of these big data challenges have been presented. And nowadays we have, or mining companies or governments, they've accumulated huge amounts of data, may be geophysical or geochemical. Huge data sets are available out there, but here it is important to be able to know what to do with such big data sets, right? How can we extract useful information from, for example, large-scale geochemical data sets? Now, nowadays you have all these sophisticated techniques such as self-organizing maps, fuzzy logic, and artificial intelligence. Just to name a few of these buzzwords, they really become important in the very near future. So knowing about these skills is key. So I put up a few images here for you to illustrate how important it is to understand your, in this case, geochemical data. On the left-hand side, you have a map of Southeast Ireland in Europe, and this area has been, over the decades, sampled extensively. You've got lots of stream sediment locations here. I think this data set contains something like 5,000 data points. Now, being able to extract key information from this data set and therefore to pinpoint where our occurrences of mineralization are very important. So very often, exploration geochemistry is a treasure chest. You just need to know how to open this chest. You need to know the tools to apply and squeeze this data. That figure in the middle is another open source data set from British Columbia. I think it contains about 15 or 16,000 data points, an incredible amount of data. And here I try to understand how can we extract from this cloud of data any meaningful trends that could lead us towards the discovery of porphyry copper deposits. Now, this is just one graph here that was produced. There's a lot more going on there during that study. But if you understand how elements work in mineralization systems and what they indicate, such as in porphyry copper systems, if you identify the elements that are typical for advanced argillic alteration or hypogene secondary enrichment of elements, that will really help you to understand the occurrence of potentially blind porphyry deposits. And on the right-hand side, you see a quality control chart of certified reference material that was analyzed by portable XRF. Of course, all the data that I'm showing you here, all of these tens of thousands of data points, we need to ensure that the quality of it is acceptable, right? So we need to ensure that the data is telling us something meaningful and is not just any collection of random numbers. And for that, often, and well, that's a must, in fact, you need to apply quality control procedures by applying certified reference materials and so on. Now, as a geologist, you definitely have to understand when an analytical technique is not working properly. For example, here in this graph on the right, you can see that the potassium values on that PXRF, that portable XRF that was in use, is really quite underestimating the certified value by about 1,500 ppm or so. Now, you need to recognize this as a geologist, because if something similar happens for your mineralization suite, then you might well underestimate the potential mineralization that is there and available. Okay, so best practice quality control is very much important if you deal with such big data analytics. Okay, moving on to the next slide. I believe that you should think about the willingness to have an open mind for new technology, despite the availability of proven traditional methods. And key point here is that our industry, the mining industry, moves on, the industry develops, and it improves. So techniques that have been successfully used 50 years ago, they might still be valid nowadays. However, as technology improves, there are better technologies coming out nowadays that can really help us to gain the cutting edge on our mining and exploration. So developing an attitude towards change, not being resistant to change, and embracing these new ideas and technologies is very important, right? And for example, key things that drive our industry nowadays are, for example, drones. Drones really have picked up in the last 5 to 10 years, and nowadays it's very common actually that you can mount a magnetometer onto a drone, like you see on the right-hand side. And whilst in the past airborne magnetic surveys, were conducted at quite wide spacing between the sample lines, it's not uncommon that if you've got a flat area, that you fly a drone at 10 meters altitude and 10 meters sample line spacing, and that really will give you an exceptional data set that can be used. So I think you should watch the space, and it's maybe not a bad idea to, if you have the chance to maybe get a drone driving license, so that you can officially and legally drive drones or fly drones, and perhaps they can become important in your job later on. A few other technologies that are currently being developed is the so-called lab on the rig. So traditionally, you drill a borehole, you extract the sample, maybe have a portable XRF that you use to quickly sap over the samples and determine the content of metals in there, and then it's been usually sent off to a commercial lab somewhere else. However, really, nowadays, people are developing and companies are developing the so-called lab on the rig system, which allows a really fast turnaround of samples on your work site. And this is, of course, very important implications for the turnaround of samples and for the ability to make decisions very quickly. And the last point here about mine automation, you may have seen these videos of the big mining giants in West Australia, where they sit in an office in Perth, and they are driving trucks remotely a couple of thousand kilometers away using remote equipment. Now that is just a starter into the mine automation direction. Maybe it's perhaps more important for mining engineers, but definitely one of the key new technologies or areas of new technologies that is currently being developed. Moving on to the next slide, I guess to wrap the top 10 skills off, I believe it is also important that we learn from successes and failures. And there have been many different successes and failures in our industry, in mining, and we need to learn from those. I mean, probably one of the classic failures over the last 2 or 3 decades definitely has been this so-called pre-X situation. Maybe you've watched a few years ago in cinemas the movie Gold, pictured on the bottom, which is basically displaying this event that happened in the 90s in Asia, where investors and geologists have misled the stock exchange and other investors into believing mineral deposit was of great value, and that of course boosted the share price considerably, only to turn out that it was all fake and all fraud actually. That event led then subsequently to a strict implementation of these resource reporting codes, in the hope that such events are minimized or do not happen in future again. Now, this pre-X is one of the classic examples of a failure recently. However, that needs to be seen against all the successes we have also in the mining industry, such as remote exploration technologies, mine automation that I mentioned just earlier. So it's good to be able to read into such case studies of good and bad aspects or developments that have happened and learn from those. We want to not repeat the same failures that we've experienced in the past. Yeah, so we really need to ensure the application of these learnings, and we need to think about how do we run our exploration programs, right? How can we redefine and streamline the strategy to drive and develop projects, and also that you need to consider innovation, talent, and people development. All of these aspects are running into this learning from successes and failures. All right, so I think we have another poll coming up. Sorry, I lost the word here. Before we move on to how we acquire these skills, I would like to ask you, how do you think you acquire new job-relevant skills? Are you studying advanced degrees like master's or PhD degrees? Are you attending presentations at conferences and seminars? Are you attending networking events and learn from other people? Or do you just learn by carrying out a job during your daily work? So please choose one of these options, and let's take a look at how you guys believe you can acquire new skills. Okay, I've made my choice here. Let's wait a few more seconds. All right, Deanne, if you would like to share the results of this poll here. Excellent. Okay, so we have a clear winner here. 56% of you believe that job relevant skills can be actually learned on the job. So for example, you're running a project in the outback and someone asked you to investigate logistical or procurement issues, solve them, you learn it on the job. Well, I think that's a very valid view. We've also got some other opinions here. People like to attend presentations at conferences or attend workshops, learn from experts in their field about certain techniques, and studying advanced degrees. Yeah, all very relevant. So thank you very much for this poll. And let me quickly, and I appreciate we're running slightly over time here, give you my opinion quickly on how can you obtain these skills. Well, first of all, these technical skills that I was talking about, as I said in skill number 1, these basics, really they should be, you should learn them during your bachelor studies, your undergraduate studies, such as rock identification, a bit about ore deposit geology perhaps, and a mineral identification. Really then, advanced master's programs are usually a very smart way of getting these specialist skills that you need for your job. That's why we have advanced master's programs around the world. My recommendation for you, if you're at this stage, is to choose your study programs wisely. During your undergraduate study, if possible, I recommend you to attend mineral exploration or even mining engineering modules. So to get a broad overview of the techniques that are used in the mining industry. If you do a master's, either after your undergraduate or if you come back from from industry, down there you see a professional master's, right? So if you have a couple of years experience and come back, my strong recommendation is you need to do this at a reputable mining school with, in bold letters, a practical or industrial focus beyond the usual ore deposits module. Right? Many universities offer an ore deposit module where you learn about how different deposits form, how you can study them by optical petrography. I think that's what one person mentioned earlier. Now, that's the standard, but really it does not necessarily cover the skills that you need when you're out in the bush and trying to find an ore deposit. So please, my recommendation, if you choose advanced study, try and look for the mining schools which have tailored program and cover all the techniques you need in geochemistry, geophysics, site investigation, and so on. It is also a very good idea that if you spend 5, 10, 15 years in the industry and you would like to return to do a master's, that's not a bad idea. And I know several people who do this to boost their skills in a specialist area. And mostly these people have a clear idea what they want from the study. Right? So they've done their 5 or 10 years in industry, and they know exactly where they need to improve their skills, and that's how they target, to get this formal education. If you're thinking of moving into a more managing role, like becoming an exploration manager or director, it's also great if you consider doing a Master of Business Administration. Right? Because this will allow you to gain skills on marketing, on setting up companies, on finance, and they are usually tailored to actually industrial projects and career paths. The soft skills, on the other hand, these are what you usually do not learn at university. remember the logistical, the health and safety, or the community skills. This is really practical experience that you need to gather on the job. And mostly students who seek these soft skills, I recommend you engage in local societies, student chapters. We've heard earlier from Deanne that the FSEG is running 118 student chapters. You can engage in sport clubs or volunteer for positions of responsibility, because this exactly will improve your management and your leadership skills. And for the professionals amongst us, let me move on to the last slide about continuous professional development. I think I showed this last time as well. And really, when I started off my career in mining, I thought that the only way I can develop is by attending expensive workshops and courses. That's what I thought at the beginning would be how I learn new skills. But actually, time has taught me differently, and is really a range of activities you can do to improve your CPD, your continuous professional development. Whether that is participating in team meetings and presenting your results to the wider team or to management, or whether you can get a secondment or placement to a mine site or to another project, to another country for a couple of months. It could be that you shadow a very experienced person in your organization and you learn about how experienced people carry out their jobs. That is really valuable, I believe. You could attend networking events, or in some parts of the world they're called mining sundowners, where people meet informally, chat about life, chat about developments, and you can learn a lot from people attending these events. You may want to consider attending conferences or society events. Just last week we had the FSEG annual meeting in Santiago. I couldn't attend myself personally, but this is, of course, if you manage to attend, it's a great event with many different participants, which allow you to listen to a state-of-the-art science talks and network with people. So all of these aspects here on the slide are really forming your CPD. Very often in your professional development, if you're a registered geologist or chartered geologist, or in North America it's a professional geologist, you need to maintain a record of your professional development. And those are just ideas how you can boost up your CPD beyond simply attending any workshops or courses and listening to people. Okay, so this slide, of course, will be available later on, and please feel free to consider some of these aspects presented here. Great, I think this was the last slide. Let's move on to a question and answer session. We have a number of questions here, and quite a few actually. Let me go through, let me find one that I can answer quickly. What skills does a PhD student need to have at the end of his PhD to work in mining companies? Well, quite often as a PhD student or someone with a PhD degree, you're regarded as a specialist person, having studied a topic in great detail for a number of years. So here I would suggest that you try to show or demonstrate experience in a number of aspects that are unrelated to your area of PhD study. Okay, so if your PhD was on, I don't know, nickel copper PGEs, maybe you want to present skills that show a wider spectrum of understanding of the minerals industry, of exploration techniques, and of how to evaluate ore deposits. Let me move on to the next question. Well, here is one. At which frequencies do you analyze seismic information? I'm afraid I cannot answer this one. I'm not a seismic interpreter. Sorry, I can't answer that. How do you think an academic and research-based geologist could fit in a mining company? Well, there are a number of ways how you can fit into a large organization. For example, if you're a specialist in a certain area, you could become, and you've got some experience, you could become, I don't know, a principal geologist in remote sensing techniques and really drive this aspect of geoscience in a company. Let me go for another one. Yeah, an important comment here. What about geological 3D modeling software skills? Is it still worth learning modeling? Yeah, thank you very much for mentioning this. I think I actually didn't have it in my slides, but this is exactly when it comes into big data analysis. Of course, it's important to learn about how to produce 3D models, how to operate the software, and especially how to know the advantages and pitfalls of such software that are currently used on mine sites. Yeah, so yes, definitely improving your skills here are key. Another question is, around a geologist could be able to deal not only with technical knowledge, but more important, it is to develop management and soft skills. Absolutely. If you want to be around, if you want to be a showcase and demonstrate experience in many different areas, it's not just important to know your rocks, it's also important to deal with logistical soft skills and management skills. It's absolutely key. And the last question here, sorry, here again. Are there any mentoring opportunities for geologists returning to the industry? For example, women who have taken time off to look after a family. I cannot comment this specific case, but I know that there are definitely in large organizations, there are mentoring opportunities where, as I said, like shadowing almost, where more senior people look after you and allow you to, to speak to them, and you get their professional advice and direction, if you like, how to settle back into the job and how to advance. Excellent. Okay, thank you very much for all these questions. It's been really great to get such engagement from you guys. We shot slightly over time, so I think we should cancel it here. And I just wanted to let you know that during the next webinar, we will really dive a bit deeper into the technical skills, whereas the two last webinars were more about how to start and develop a career in mining and what skills are really important. Next time, we're going to dig into more technical aspects such as source sampling, target generation, big data analytics, some of the aspects that I have just mentioned earlier on. So I'm hoping that you will that we will meet again during the next webinar in a few weeks' time. And yes, I hand over to Deanne. Thank you very much.
Thanks, Benedikt. Just a reminder to everyone, our next webinar is on November 13th. This is a slight change from what was previously on the schedule, but if you've already registered, you'll see an email with the updated date. And then you will see a survey following the completion of this webinar, and we ask that you give us your input. We really appreciate your comments. And that there will be an archive of this event posted onto the SCG YouTube channel, as well as, and it will be linked on the SCG webpage that you originally registered for that. And with that, I will thank you all for joining us and hope to see you next time.